know. This presentation is, I just recently got it put together because we're just finished a building sub-council meeting and I had a lot of stuff to get ready for that. But so bear with me as I go through this and try and answer your questions at the end. But just want to bring up the information in relation to that 12-story encapsulated mass timber construction stand data that was issued in February of this year. Just to let you know, that was direction from the minister's office to see if we could accommodate this. And if we couldn't accommodate it, that would have been our response, but we were able to accommodate working out the stand data. So here we go. Let me see if I can get this thing working. There we go. The stand data, of course, is worked on by the building team. Our director, James Orr, is director for building, fire, energy, and accessibility, and he's actually also the fire commissioner for Alberta. There's myself, provincial building administrator, as well that I work with Linny Say. She's a provincial administrator for barrier-free policy, and we work together, especially when you see any of the barrier-free relaxations that she deals with all those, and then I do look at them and review them for signing. Nabil Habashi, some of you might know him already. His position changed slightly. He's now, other than being a building technical advisor, he's our energy code specialist. Our building technical advisors is listed. There's 5 other ones in Edmonton office, 2 in the Calgary office, and 2 in the Red Deer office. So the building technical advisors worked on this stand data when they were working on it. The others had to cover the extra time that, or all the other usual business that's going on while they were working on the stand data, because we were given a very short timeline. Encapsulated mass timber construction. It is a new construction type for the 2020 National Building Code of Canada and the 2020 National Fire Code of Canada that is not out yet. And there were proposed changes for the 2020 National Building Code of Canada to include the encapsulated mass timber construction. And that is going to be that new construction type that is currently not identified in the 2015 National Building Code of Canada or in the Alberta Building Code 2019 edition. So we'll go a little bit on what the changes are proposed and intended to be in the 2020 National Building Code of Canada for Division B. The change requests package, of course, submitted by the Canadian Wood Council and their partners in providing the requested changes. The changes went through the Standing Committee on Fire Protection, and a task group and 5 sub-task groups were formed through NRC from the Standing Committee. And those task groups or sub-task groups would include members from the other standing committees with the National Research Council that oversee the national construction codes. There were a list of 5 or 25 potential issues and concerns developed, and these issues or concerns had to be addressed through the task group and working with their partners. The draft proposed code changes submitted to public consultation were in fall of 2017 and 2018. So those were all addressed at that time, with the final public consultation done in the fall of 2019. So those proposed changes had gone through with the public consultation and addressed back from the fall of 2019, with the final submissions being addressed early in 2020. And those proposed changes had gone through as supported to be into 2020. So that's what we were waiting for initially, was the NBC 2020. And the 12-story EMTC code references 48 MBCC 2020, the National Building Code of Canada, included Group C up to 12 stories, Group D up to 12 stories. Of course, those are all sprinklered. And they did have these are the code provisions that's intended to be in the 2020 National Building Code of Canada. Of course, sprinklered, height not more than 42 meters, measured between the floor of the first story and the uppermost floor level, and it does not serve a rooftop enclosure for elevator machinery, stairway, or service room, is only for servicing for the building. The building referred to is permitted to be of encapsulated mass timber construction or non-combustible construction, used singly or in combination. That would be the hybrid construction, where they typically do the podium or a number of floors at the base with non-combustible construction, and then go with encapsulated mass timber from there on. Now, the current requirement is non-combustible construction, of course, is degree of fire safety attained by the use of non-combustible materials for structural members and other building assemblies. Combustible constructions means that type of construction that does not meet the requirement for non-combustible construction. Oh, just stand by one. Non-combustible construction and combustible construction, as defined terms, they're convenient, although not necessarily accurate categorized labels. Could just as easily say this type of construction is X, and the other type of construction of Y is everything that's not X. That's pretty broad, and it leaves room for other definitions or other types of construction now that there is more advanced technology to address that. Again, in the NBC, any building that does not follow all the requirements for non-combustible construction, including 3151 to 31524, which includes fire blocking, flame spread ratings, connected walkways, plenums, insulation, and coverings on piping, is considered combustible construction if it does not comply with any of those. Oh, just having a little trouble with my PowerPoint here. Just stand by again. Okay, tall buildings in current codes are required to be non-combustible construction. There would be a required fire resistance rating of structural members of 2 hours. They require automatic fire sprinklers that would be under NFPA 13, and that's currently on a limited height on a limited area. That's considered to provide an acceptable level of safety. However, for the 2020 NBC, under prescriptive tall wood buildings, non-combustibility is it's an elemental concept, but non-combustible construction is only a standard that has proved satisfactory for tall buildings and some other situations. When construction using combustible materials is developed that satisfies the conditions, the standard should be changed to permit it. Non-combustibility will always be one, but not necessarily the only solution. And this is from the notes of Mr. Ferguson from the NRC. In the technical notes, and that was back in 1964. So it was recognized that maybe there's something else, but at the time that solution wasn't available, and this is where we are now. Again, Under tall wood buildings, the general premise was to develop a set of provisions that achieves the current level of fire safety when wood structural elements are substituted for structural elements of non-combustible material. This again is where we come to the mass timber construction with the concerns and issues brought up by the sub-council or sub-task groups must be addressed to provide that approximately equivalent level of safety, or it's an alternative solution for us under the stand data, but that is going to be in the 2020 National Building Code of Canada. So again, non-combustible construction, then there's structural elements required to be of non-combustible materials replaced with wood elements. So that would be the mass timber elements, and then what additional requirements are needed, to address the situation so that the acceptable level of safety is maintained in a building built with mass timber. So we need to, what this is saying is that we need to develop a structure that meets non-combustible construction safety requirements, but using wood elements with other additional requirements. And into that, we come into the proposed third type of construction, encapsulated mass timber construction. So we have the defined term for non-combustible construction, which we've gone through before. Construction means that type of construction, degree of fire safety attained by use of non-combustible materials for structural members and other building assemblies. Now, the third type of construction, encapsulated mass timber construction, means that type of construction which a degree of fire safety is attained by the use of encapsulated mass timber elements with an encapsulation rating and minimum dimensions for structural timber members and other building assemblies. So that revises the definition of combustible construction, means that type of construction that does not meet the requirements for non-combustible construction or encapsulated mass timber construction. So that is the third type, which we are working, encapsulated mass timber construction. Typically, I'll refer to that as EMTC as I move along. And encapsulated mass timber construction encapsulation rating. And that's a new defined term as well. Encapsulating rating means the time in minutes that a material or assembly of materials will delay the ignition and combustion of encapsulated mass timber elements when it is exposed to fire under specified conditions of test and performance criteria or as otherwise prescribed by this code. An encapsulation rating determined via the new test method of the draft standard ULC S146, standard method of test for the evaluation of encapsulated materials and assemblies of materials for the protection of mass timber structural members and assemblies. And this encapsulation rating, of course, would have to meet the minimum 2-hour standard as currently required for non-combustible construction. The draft test method for mass EMTC, standard time temperature curve from CAN ULC S101, horizontal configuration, fire from underside, so that's tested from typically under the floor. Minimum size of assembly to be tested is 3.66 meters by 3.66 meters. The maximum average temperature increase of 250 degrees C at the interface of the encapsulation materials and wood substrate. The maximum temperature increase at any individual point of 270 degrees C at the interface of the encapsulation materials and the wood substrate. Now that is what was proposed and is already gone through, that is going to be in the National Building Code of Canada 2020. But with initially, it had been anticipated the next edition of the Model National Codes would be available in 2020, and typically would be November or December of this year. And Codes Canada has announced that the publication date has been updated for the national model codes, and it has been extended. The next editions are anticipated to be available in December 2021. That would be the National Building Code of Canada, the National Fire Code, the National Energy Code for Buildings, and the National Plumbing Code of Canada. Those would be all available in December, or anticipated to be available December 2021 as all together. And that would avoid anything showing up any sooner or later. Well, we don't know the exact time yet, but you don't want them either showing up in the middle of the construction season as well. And the Alberta Codes update, as we are in line or going in line with the national code editions, and we use the national codes as the base document. So as the next national code editions are anticipated to be available in December 2021, the codes would not come into effect in Alberta till January 2023. So that would be the first day of the month following the 12 months from date of publication. And that is in relation to our timely code adoption as regulated for the first day of the month after 12 days of the publication of the code. So the anticipation of that would not see the 12-story EMTC until at least January 2023. And from the minister's office, that indicated that would be a stretch for us to wait that long, and through the proposals from the minister's office and ourselves, we indicate we could put that together earlier than waiting for the new code to come out. So that would be the 2021 National Building Code Alberta Edition and the 2021 National Fire Code Alberta Edition. Anticipated, that's what they would be. We are working with the National Research Council on harmonization to the national codes and identifying the variances of the Alberta Code from the National Building Code of Canada and the National Fire Code of Canada. And we have identified that in one of our projects we've worked on with the National Research Council. So we were working in collaboration with the National Research Council of Canada, and for the EMTC, there were 30 National Building Code PCFs, or proposed code change forms, and 4 National Fire Code PCFs. That equivalent to, that worked out to approximately 300 or just over 300 pages of proposed code change forms that included all the technical requirements, the objectives, the intents, the justification, and the safety analysis. These documents were consolidated by NRC for us into 56 pages of the actual code text only. And the PCFs have been approved for inclusion into the National Building Code 2020. The community and technical support, that's our branch name. It's no longer safety services, just to let everyone know. That has gone from, the email has stayed the same at safety.services, but the name is community and technical support, no longer safety services. And the division name is actually technical and corporate services, no longer public safety. So technical advisors, using the documentation from NRC, correlate the information into a sequential format for use for us into the stand data. That included 203 files, numerous iterations and drafts from the code text to stand data format. And also, we were under a timeline in regards to getting this work completed. We were informed of doing this work in January of 2020, and we were initially given a timeline to be finished by the end of February. And basically, doing the stand data is in effect drafting up in a similar manner as writing the code, because it is code text we use from National Research Council. Those 56 pages of code text turned into stand data with 26 pages of technical information, and it must be used in conjunction with the National Building Code Alberta Edition and the National Fire Code Alberta Edition. This stand data is only dealing with the portions specific to EMTC, but the rest of the codes still apply, except for the variations as permitted in the stand data. So the initial deadline was end of February. Then we were told it was the third week of February. And then we were told it was the second week of February. And we were able to get this finished by February 20th, I believe was the original issue date. So we were under a bit of a timeline and under the gun to get this worked out for the minister's office. And as both a building code variance and a fire code variance, because there are fire code requirements as well. So again, must be used in conjunction with the National Building Code Alberta Edition, 2019 Alberta Edition, and the National Fire Code 2019 Alberta Edition. Some of the standards that are referenced in the stand data are identified in the slide. Now, the 12-story encapsulated mass timber construction, again, encapsulated mass timber construction means a type of construction which is a degree of fire safety attained by use of encapsulated mass timber elements with an encapsulation rating and minimum dimensions for structural members and other building assemblies. Initially, we were challenged on this stand data that were concerns brought up of building a 12-story wood building, and many of the proponents that had concerns on building a 12-story wood building were under the thought pattern that it was stick built with light stick framing up to 12 stories. And once we clarified the concept of mass timber, which they were not aware of, and the encapsulation requirements to provide the fire safety, then the proponents that had the concerns were satisfied with our response. That included the Alberta Firefighters Association, and as what I believe it was some of the fire personnel and on the fire discipline that were concerned with that, as well as some on the building discipline that at the time were not aware that this is mass timber construction that we're dealing with. And then again, in addition to the mass timber elements, the encapsulation rating that's required over and above the mass timber, that means the time in minutes that a material or assembly of materials will delay the ignition and combustion of encapsulated mass timber elements when it's exposed to fire under specified conditions and tests. As you can see from this slide here, this is the exposed mass timber while it's going under construction. And here they have on the second picture, there's still the exposed mass timber at the ceiling levels, but they have the concrete flooring installed that has to be concrete or gypcrete of 1.5 inch thickness installed on top of the mass timber flooring. So that's partially encapsulated right at this time, and that's how they're attaining the fire protection ratings. Okay, the hybrid mass timber concrete core construction. As mentioned, that this is the hybrid mass timber core from the 18-story UBC tall woodhouse building, and they've built the podium, as you can see down here. That is concrete, a concrete podium, and if you just see through here, the two cores, those are concrete cores that contains the elevator shafts and the exit stairwells for the building. That is just showing the exposed mass timber. It would not be up like in this manner under construction. Okay, and under the mass timber structure, they do have steel connectors and that join all the floors together and the columns as well. That's where the floor assemblies connect in through those structures, and those are the mass timber structure. And the partial encapsulation, this is the CLT floor slabs here, and glulam columns and steel connectors. Then during construction, they must do partial encapsulation. So that's where they would do the floor with the concrete on top. And just under here, you could barely see it, with one layer of drywall to do the partial encapsulation. Then once they are going for completed construction, all elements are completed. So that would be the additional 2 layers of drywall at the ceiling, and then it's fully 3 layers on all exposed mass timber. Well, most of the exposed mass timber. There are certain allowances for a certain amount of exposed elements, but not the structural elements. So under this same tall woodhouse drawing here, that they do show the completed structure as fully encapsulated, so you would see minimal exposed mass timber elements within the building. So that was the other thought, was it was fully exposed mass timber throughout the whole building, and that was another concern that was initially brought forward to us when at the time we identified that everything would be encapsulated. Now, the key safety requirements for mass timber building construction. One of the big issues is protection during construction of the building, and again brought forward to our attention by the fire services. The changes made to National Building Code 2019 Alberta Edition and the National Fire Code 2019 Alberta Edition. The fire code addressed high-intensity residential fires in 2009, established fire site security measures to protect the building against accidental or deliberate ignition of fire, as well as hazards protection to the public. And this carries over into the 2019 editions of the fire code, and this criteria is carried into or highlighted within the stand data for EMTC. Okay, the national standards for mass timber buildings of up to 12 stories maintain protection during construction of the building and establish even better protection standards while the building is under construction. The building may only be occupied once fire safety features are fully enabled. And here is just a picture of the UBC 18-story. They do have some allowances for more exposed timber under all their variances and special engineering and allowances that were for that building, with all safety criteria addressed. So you wouldn't see this scenario in the current 12-story buildings as much exposed timber, but if it's interior finish, that's different. exposed, the encapsulated or the mass timber would be encapsulated. So you could see interior finish that's permitted by the current code for non-combustible construction building. Of course, there is mandatory sprinkler systems required. Apply to balconies and concealed spaces in residential buildings. Requirements for mass timber building construction are consistent with this expanded protection using the National Fire Protection Association or NFPA 13 standard for sprinkler systems. It would not even relate to the NFPA 13R, which is only for buildings up to 4 stories, residential construction. Of course, there's a fire rating of roof coverings to prevent fire growth and the spread of fire across the roof covering, which could lead to the spread of fire to occupy parts of the building. Class A roofing is required, and that's within the code, but that is specific as well to identify that that's required for the EMTC building. There's structure and earthquake design. National requirements reduce the risk of Storey seismic behavior that can lead to building collapse. As well, there is documentation that indicates that mass timber buildings do have a better performance for earthquake resistance than typical non-combustible construction. That's something that's the designers have all done, so that's outside my scope. Okay, and the ceiling and drainage. Okay, the standards require designers to consider wood shrinkage in their designs to protect against moisture penetration of the wall and roof system of the building or envelope. So this is inherent in the wood construction. There is going to be a certain amount of shrinkage, and that has to be addressed in the design. Emergency power. Duration of emergency power for fire alarm and emergency lighting is increased from 30 minutes, which is typical, to 1 hour for the buildings of EMTC. So that is over and above what's typically required in a typical non-combustible construction or another type of 12-story building. Prohibitions of certain types of mixed uses. These standards prohibit combining residential with other commercial uses at the upper stories to reduce the fire load and risk of fire to occupants. At the lower stories, mixed use is permitted. The strength of modern mass timber versus concrete. And despite being 5 times lighter than concrete, cross-laminated timber, or CLT, has comparable strength per weight ratio to concrete, and a multi-layer wooden panel spans in 2 directions. Each layer is placed crosswise to the adjacent layers to increase its stability and strength. Buildings using mass timber carry the same strength as concrete. This strength also enables mass timber buildings to commonly outperform other systems in terms of cost and life safety in earthquake zones. As you can see, the timber strands are going, or the mass timber, they're 1 layer going in one direction, and then the next layer crosses in the other direction. So that's how they're attaining their strength, using the certified or acceptable adhesives. EMTC, this is a basic method for protecting all construction materials from fire. It can delay the thermomechanical effects of fire on structural elements, as in the case of traditional non-combustible construction, as well as delay the contribution of wood structural elements to the fire. That again is the encapsulation rating. In the encapsulation rating, not less than 50 minutes over and above the rating of the mass timber itself. 2 layers of type X gypsum board, each not less than 12.7 millimeters thick, not less than 38 millimeter thick gypsum concrete or concrete topping, or other non-combustible material of assembly materials that provide an encapsulation rating of at least 50 minutes. Oops, sorry. That is the additional requirement over and above the structural member itself. There's a stand or a table, sorry, for the minimum size requirements for structural timber elements to be considered mass timber. That is included in the table within the stand data. They've been developed to provide assurance that the timber elements will exhibit the fire performance characteristics of mass timber rather than of lightweight small dimensional wood elements. This means that after charring, the timber elements will still be thermally thick for the required fire resistance rating. So that's why the minimum size requirements for these elements. Table 2, there's minimum construction requirements for exposing building face. That table is or table 3, sorry, included in the stand data. Requirements, of course, the EMTC construction is limited to a height of 12 stories, sprinklered throughout to NFPA 13, minimum 2-hour fire resistance rating, limited maximum building area for any height. Group C is 6,000 square meters per story. Group D is 7,200 square meters per story. So permitted in all stories, Group C or Group D for all up to 12 stories. Permitted with Group C. Group E can be permitted on the first and second stories. Group A Division 2, first, second, and third stories. And storage garage can be built below the 5th story. So there's increased fire resistance rating for separation between some major occupancies. Permitted with Group D, Group E, first and second stories again. Group F, Division 2 or 3, so that's first and second stories. Group A, Division 2, first, second, and third stories. Again, storage garages below the 5th story. And again, increased fire resistance rating for separation between some major occupancies. Encapsulated mass timber construction, they limit the height of the uppermost floor level to 42 meters above the first floor level. And so that would be the first floor to the floor of the uppermost story to 42 meters or less. And again, as I indicated, the stand data has to be used in conjunction with the building code, and the requirements for high buildings applicable to EMTC buildings in which the floor level of the highest story is more than 18 meters above grade. So that's once any of that is in effect, then high buildings criteria come into play. The additional mass timber requirements that, as indicated, that would be what are those additional requirements? And the materials permitted shall conform to subsection 3.5 or these requirements for EMTC. Combustible roofing materials, combustible window sashes and frames, exterior cladding, combustible components in exterior walls. And this is indicating what limits you have on those elements. Nailing elements, combustible flooring elements, combustible stairs, combustible interior finishes, combustible elements in partitions, concealed spaces. So it's not saying that you can use combustible stairs anywhere, but it does provide for using combustible stairs in certain locations. The floor system for a raised platform, for example, in item 2.9 of the stand data, is permitted to include combustible subfloor and combustible finished flooring. So that's still on top of the encapsulated encapsulated mass timber flooring. And wood stairs are permitted in a suite, but they need to conform to items 2.2 to 2.7 of the stand data and items 2.9 to 2.12. So that's wood stairs or combustible stairs within a suite. For those that have two-story suites in a high-rise, I guess. Exterior cladding, there's non-combustible exterior cladding and or tested in accordance with CAN ULC S134 fire test of exterior wall assemblies, and or there's three approaches for combustible cladding, permitted combustible cladding. Here, combustible cladding, approach 1, that represents not more than 10% of each story, not contiguous, I'll work on that word, over more than 4 stories, not more than 1.2 meters in width, separated from other portions of the same story by 1.2 meters, separated from other portions of adjacent stories by 2.4 meters, and a flame surge rating of not more than 75. Exterior combustible cladding approach 2 represents not more than 10% on each story. Excuse me, I think I provided a picture that may indicate more than that. That is a UBC building, but that would be a flame spread rating not more than 75, and under that one there are special requirements, so don't mind that picture that I included on this one. So again, separated from other portions of adjacent stories by 2.4 meters, not contiguous across adjacent stories. And approach 3 represents up to 100% of the first stories, not located not more than 15 meters from a street or access route. So that may look something like this for exterior combustible cladding. So for typical EMTC 12-story, you would end up with not that much combustible cladding. Another scenario could be like this for exterior combustible cladding. So like I said, that picture I had there was a little misleading, but that is not for 12-story EMTC. And finally, there's another scenario, something like this, but you could see the separations must be between elements and for the combustible cladding, and then their criteria for that type of combustible cladding. Encapsulated mass timber construction. Again, what I am using is the 18-story tall wood building that I had permission to use these pictures. I didn't want to get copyright protection issues with using someone else's pictures, so these ones I had permission to use. So that would be the building again at the UBC or University of British Columbia, and this is part of the process they were going under for the encapsulated mass timber construction. As you can see, they're doing the wall panels prefabricated offsite. This initially, that's the podium that they're working on. You can see these steel wraps around here. That is forming the basis for the encapsulated flooring going, the concrete going on top, or gypsum going on top of the wood structure. Again, there's a side picture here, but as you can see, the panels are going in. There are full-size panels. These are all prefabricated off-site. This is part of the finished building that they were able to provide some drawings. So you can see what's a studio bedroom. So you don't see any wood elements in there. That's all encapsulated. and the interior walls are typical metal stud and drywall. This would be a quad unit. And here is the study space where they do have interior finish that is wood, but that's not part of the structure. They did some fire tests of rooms with exposed wood surfaces in encapsulated mass timber construction. That was done by the National Research Council. Their fire test room set up with the big furnace and the hood, and basically they took raw exposed or mass timber to do their fire testing. And the fire tests were, they put in the wood cribbing for the fire load, and the fire load is the average residential fire load density of 550 megajoules per square meter. So that's still a pretty good fire load. And then they did the fire test and they put it on fire. And basically you could see the exposed mass timber, and then they did the criteria where they encapsulated portion of the ceiling assembly and the wall assembly. Okay, so there's some more fire tests, and basically here they show the columns, exposed columns and beam, and then the rest of the room was covered with a layer of gypsum. Again, they set that on fire to see what happens. And here's the exposed column and beam after it was burnt up. So as you can see that from here on the one side, you can see that there's still some structural integrity within the exposed beam. And then from the column, it's charred, but there's still a certain amount of mass left within the column. Again, here's the end view. You can see the exposed beam, that is the structural integrity is there. And that charring, once it's charred, is providing a protective layer around the mass timber. And here you can see where the drywall is burnt off, and here's where that beam was holding up. So that still has some charring here. And again, the structural integrity is still there for their design. And just some more fire tests. Again, showing the charring that forms the it becomes a sacrificial layer of the wood. Once it's charred, then it maintains the integrity after that initial char. And they just some more pictures of fire testing. They did burn those rooms up pretty good. We'll go through this pretty quick. Nail laminated compartment fire tests. They did the same thing with nail laminated testing. So this is not CLT, as nailed and laminated pieces of lumber. Again, they built a compartment and they burnt it up. Again, the fire load, the same average fire load. And initial tests, they're showing the tests of the nail laminated system. Initial tests did not work out so good, but they had different adhesives that they used later on. And this is a test after 2 hours of burning. So just to show you that the does char, but the initial mass timber holds up in place. Okay, whoops. Now the EMTC stand data user's guide, that was just developed to assist basically providing the applicable code references from the stand data have been included in this user's guide. And I did forget to include that basically within that stand data user's guide, the portion of the stand data with the code references are all hyperlinked. So we could open this up, I believe. Can you see the stand data on there, Katie?
Yep.
Okay, here the user's guide that was hyperlinked in, so it's freely available. It's on the Safety Codes Council site, and basically you go to the stand data, and then it talks about the appendix, which is the requirements for a 12-story. And once we get past this first section with the tables, it does make reference to a code article here. Then within that, you click that and it'll go to 32214. That was the code article, I believe. So it will always go through, and all those code articles have been included within this user's guide, and it is copyright permission provided by the National Research Council, because it was not just a couple of pages or a couple of lines. So all of this, if you go through it, they're all hyperlinked within that document. Again, you still use it in conjunction with the code, but I try to package it so that the real applicable sections will send you or all included within this user's guide. So again, if you go for, I guess it's not, once you download it with your Adobe Access, then you can navigate it a lot better than I can right now on the website. But again, here's requirements for 33423, 33423, that's included in there. So as you go through that, all those are hyperlinked. There's a couple at the very start that aren't hyperlinked, but they're all the way through. The rest of them are hyperlinked. If anybody does find something that's not working, let me know, and I can review it. But I did have it reviewed by other stakeholders other than within municipal affairs. So hopefully that's helpful. And we'll go back to, how do I go? Oh, here we are. Back to the user's guide. One of the items that was brought up with the electrical discipline is wires and cables. Oh, it's for them, it's not non-combustible, so can they use regular Lumex? No, because the building, except as otherwise provided in this variance, building or part of a building of encapsulated mass timber construction shall conform to subsection 3.1 of the NBC-AE, which is a subsection for non-combustible construction. So you go to 3.1.5.21, wires and cables. The wires and cables, they're required to be FT4. Yeah, well, I guess that'll be according to the electrical guys. We'll have to look at that, but they cannot use regular Lumex. They does provide the ratings, the same requirements as a non-combustible construction building. Some mass timber surfaces that can be exposed within the building. There's the table for that. I'll go through probably another 5 minutes, I think. Oops. Then we come down to fire safety. That is references to the National Fire Code 2019 Alberta edition. So they talk about when a building is already completed, any damage or removed encapsulation material shall be repaired. No different than saying it has to be repairs to fire rated walls that have damage, fire separations that have damage. That's the same continuing requirement, just identifying the encapsulation ratings for the various structural members within EMTC building. Additional fire requirements on construction site is, of course, construction access, standpipe installation, and protective encapsulation. there's only 4 stories are permitted to be unprotected during construction. And so the encapsulation has to go up with the building. And typically there's the 4 stories that they're working on. They're just preparing the 4th floor to be encapsulated. So there's a minimum of 25 minutes encapsulation rating is needed for 80% of the area of mass timber and 60 of the ceilings and 65% of the mass timber walls during construction. And then again, the standard refers you to the National Fire Code Alberta edition to the identified articles that apply. Those articles are all included within the user's guide, and they are linked through within the stand data. Of course, the adequate water supply must be on site as soon as combustible or encapsulated mass timber construction arrives on the site. So that basically means you can't store materials there until you have all your water, firefighting supply water in place. Of course, the additional requirements of at least 2 stairwells shall be provided. That is, it typically is asked for 1, but 2 stairwells must be provided, and at least 2, at least 2 stairways conform to item 4.8 shall be extended upward as each floor is installed in new construction, maintained for each floor still remaining during demolition, should there be a point when one of these buildings are being demolished. Again, not more than the 4 uppermost contiguous stories are permitted to be unprotected as required by item 4.17 during construction. And again, it indicates what the material is required for that rating during construction. Let's see if we can see it here. Sorry, it didn't come out too good. If you could see the green arrow, this is 4 floors here that's unprotected, and you can see the green arrow. That floor is still the wood mass timber flooring. Oh, sorry again. And there should be an arrow right here. You can just see the red, but if you could see within this floor space, the concrete flooring has been installed. Okay, and here's the 18-story Brock Commons tall wood house time lapse. There's the podium and the cores that have been concrete cores that have been in place, the 2 stairwells, and that's required as well. And then from there, they didn't build that in 1 week, but this is week 1. They're starting the mass timber construction. So after 1 week, that's week 2. They have the base, the 2nd floor in place. Week 3, they put another 3 stories on. Week 4, they were at 2 more and just getting ready for another one. Week 5, week 6, week 7, week 8, they're just getting ready to cap off with the roof sheathing. Week 9, that's the steel frame at the top for the metal roof sheeting. So 9 weeks, that's the 18-story building there. Okay, the Brock Commons photos were courtesy of the architects, Acton Austria Architects Inc., that were the lead on that project. And I had the fire test photos and additional content provided by the Canadian Wood Council. Compliments of Mark Allam, the engineer there, that from his presentation. So questions? Have I left enough time for you there, Katie?
Yeah, we have a few questions, and I think we might even be able to get through 1 or 2 more. If someone thinks of one in the meantime, just leave it in the chat or shoot it to me in an email.
Okay.
Yeah, we have 4 questions. So this is in reference to the earthquake design.
Yeah.
Has it addressed potential damage to the existing encapsulation? And as a side note, the person says, I realize that it is timber that actually holds up better in fire than steel does.
Oh, okay. Yeah.
But the question is, yeah, about
Yeah,
the potential
that
damage
would
to
be
existing
addressed
encapsulation.
under the, just like the fire code says, any encapsulation that has been damaged has to be repaired. So any building, if you do have any drywall in it, even if it's non-combustible construction, you might have fire rating or encapsulation around a steel column or even a concrete column, but a steel column typically will have a fire protective either rated drywall around it or a fire protected coatings of some sort that may come dislodged during any kind of movement or anything else. Anything that's damaged has to be repaired, but that would be no different than any other situation. I don't know what that would be like in a full-on earthquake situation, but it would have to get repaired. How much there would be, I don't know.
All right. I should also note, I'm not a technical person, so if this question was asked and then actually addressed later in the presentation, I'm not going to be able to realize that. I'm just reading off words to me.
Okay.
They're all just words
Yeah,
to
no,
me,
no,
so I
no,
don't
that's
know.
fine.
So it's my error, not the asker's.
No,
by
just
the
read
way.
it off and I'll do the best I can. And if I can't answer it, we'll have to look into it or something. Then I can draft that response and
All right.
and go from there.
Great. All right, next question. The CLT 5-layer floors use a fire heat resistant glue, correct?
Correct. Yeah, the initial tests, the initial adhesives did not hold up as anticipated. So they had to go back to the drawing board and they came up with the new adhesive that held up so that the laminations did not come apart. So there was initial tests that did not pass, but they came up with the better glue that were more fire and heat resistant, and then the mass timber stayed in place.
All right. So questions about the 50-minute encapsulation. Does this contribute to the required 2-hour fire resistance rating?
No. They tested the mass timber for 2 hours under fire conditions, and then they encapsulated it. So the 2-hour fire conditions were tested on the raw mass timber, and to indicate that yes, it chars and burns, but the structural integrity is still there. And then they said they would do additional requirements just to say we'll make it to protect the lumber from getting charred and damaged. So that's an additional 50 minutes. Yes.
Okay. Question about service shafts. How are they to be constructed when passing through fire-rated floors, just as they were in non-combustible, or are they required conditions and added requirements?
The shafts would be all rated, just like in a non-combustible construction. Remember, the reference is that whatever's not addressed within the stand data, you follow according to Article 3.1.5. So everything within there for non-combustible construction applies. And the same, it applies for any service shaft, whether it's even a combustible building, for the ratings of the shafts, and all penetrations into and out of that shaft will be properly fire stopped and fire rated.
Okay. Let's see here. Does 100% of the structural mass timber need to be encapsulated, or is there a percentage that can be exposed for design purposes?
Yes, that was shown later in the table, the percentage that can be exposed. That's within the tables. I don't know the numbers offhand. So they do have a certain percentage of interior walls and ceilings that can be exposed, and that again, that should be followed within the stand data. Let's see if I have that
All right,
table
looks
available.
like
Yeah, so you will have some freedom of, it's not 100% covered. I'm just wondering if I have that slide back here. I don't know if I have that slide readily available. Okay, any other next question, Katie?
yeah, I think, let me see, I think we have one more came in via email. Are there any additional requirements for fire stopping at floor assemblies?
The fire stopping would have to meet the requirements of ULC S115 for fire stop systems. So it would be still a listed system that maintains a fire stop at the rated assemblies, no different than any other building that you would rate accordingly from the underside for the floors. Slightly different than non-combustible construction, but the fire stop system has to be listed for that use and for that rating. So they are 2-hour ratings through the floors. So that system has to be a listed system.
Okay, last call on these questions.
I might generate more questions. I don't know.
Yeah, more questions than these answers. Just a note to SDOs, if you haven't identified yourself to me in the chat or via email, please do so for your continuing education credits. I'll just, while we kind of give everyone a minute or two to send something in, I'll just say thanks again to ABOA and thanks to Paul for putting together this presentation. I know it was a little bit on the fly, but I'm already getting good feedback in the chat about it. So hopefully everyone enjoyed it. We are going to be sending out a survey from the council. This will just ask a little bit, mostly about the format, honestly, just so we can kind of figure out if there's some consistent technical difficulties, that kind of thing, we can troubleshoot for the future, and we can kind of figure out what sort of things you guys are interested in viewing from us again. And yeah, it looks like one more call on the email. Looks like we're good. So I'm gonna hang around for about 5 minutes. Make sure I get out all of your information, everyone's information saved, but I think we're good to go. And the continuing education credits on your account in about 2 weeks. We'll also be uploading a recording and the physical presentation in about that time period as well. And I'll be sending out a quick email to everyone to let them know it's up and where to find it.
Okay, Katie,
thanks everyone for attending.
Am I still live here?
You are.
Oh, just
Yeah,
slide 72. Let me just get it up if there. Trying to. Who put all these slides in? I don't know. Okay, slide 72 has the table for exposed interior surfaces. Okay, it is 60. Okay, slide 71. Okay, slide 71. Some mass timber surfaces permitted to remain exposed within a suite. So you do have a percentage and the flame spread rating, and that is the areas that they can work with. Okay, so that is a slide 71 of the or page 71 of the slideshow.